Hello everyone. So today we'll talk about some important name reactions from the three important chapters: haloalkanes, haloarenes, alcohol, phenols and ether, and from the amines. So this video is for the PU students and state board students for their term 1 exam. Okay, so we'll talk about the important reactions. First we talk about the haloalkanes and haloarenes chapter, and our first reaction is called as Sandman reaction. This is the first name reaction. So in the Sandman reaction, you are producing diazonium salt. Diazonium salt is prepared by treating an ice cold solution of aniline. So you will take something which is called as aniline benzene with NH2. This is aniline, and you will treat with NaNO2 HCl, and you take ice cold 0 to 5 degrees Celsius, and when it react, it result in formation of benzene diazonium salt, or here benzene diazonium chloride, which is benzene N2 plus Cl negative. So this is the Sandman's reaction. Next name reaction is Frenkelstein reaction. In Frenkelstein reaction, we will prepare alkyl iodide. So alkyl iodide are prepared by reaction of alkyl chloride or alkyl bromide with NaI in presence of dry acetone. Suppose you have Rx, X can be chlorine or bromine. So you can react with NaI in presence of dry acetone, result in formation of alkyl iodide and NaX. So in Frenkelstein reaction, you can prepare the alkyl iodides. Next, if we talk about next reaction, which is very important, called as Schwarz reaction. In Schwarz reaction, you will prepare fluoroalkanes or alkyl fluoride. So they can be prepared by treatment of RBr, which is alkyl bromide or alkyl chloride in presence of metallic fluoride. So you will use metallic fluorides such as AgF, Hg2F2, COF2 or SbF3. So in presence of metallic fluorides, what happen? Though metallic fluorides will displace the bromine, okay, result in formation of CH3F and AgBr. Next, we talk about three similar type of reaction. First reaction is Wurtz reaction. In Wurtz reaction, what you will do? You will take alkyl halide, react with the metallic sodium in presence of dry ether. You will put sodium in presence of dry ether. What you will get? You will get alkane with the double number of carbon than the alkyl halide. Suppose you have taken ethane bromide. Ethane bromide react with sodium in presence of dry ether. What will happen? This ethane bromide react with itself, result in formation of butane. So number of carbon has double and you get NaBr. So this reaction is called as Wurtz reaction. Next reaction is Wurtz-Fittig reaction. So in this reaction, what you will do? You will take aryl halide, one aryl with benzene halide, and next you will take alkyl halide, and both are reacted with sodium in presence of dry ether. What will happen again? What happen? This R and this benzene ring will get attached to each other. This aryl and alkyl group will get attached to each other. You get alkyl arene plus NaX you will get. And next reaction is Fittig reaction. In Fittig reaction, you will take only aryl halide and it will give analogous compound. Analogous is similar type of compound or symmetrical compound which treated with sodium in dry ether to aryl group will join. Suppose you have taken X with benzene with sodium in presence of dry ether. What will happen? These two benzene ring will get attached to each other, and this compound is called as diphenyl plus NaX. So diphenyl is formed only when you have taken benzene with X or aryl halide. Next, we talk about the important reactions of alcohol, phenols and ether, and first reaction is hydroboration oxidation. So in hydroboration oxidation, first you will use diborane. Diborane is B2H6. When it will react with alkene, you can use any alkene. We will take unsymmetrical alkene like propene to form trialkyl borane. Okay, so 3 alkyl group will attach to the boron as additional product. This is further oxidized to alcohol in presence of H2O2, which is hydrogen peroxide, and aqueous NaOH. Suppose you have propene and you have added BH3 twice, called as diborane. So we have separated the H. What happen? When it will breaks, it give H plus and BH2 negative, and this addition is against the Markovnikov principle. So this is anti-Markovnikov addition. Negative part will get attached to the carbon which has more number of hydrogen, and positive part will attach to the carbon which has less number of hydrogen, result in a formation of first additional product. Next, what happen? You will again use propene. This BH2 will break into BH negative and H plus. H again will add to the carbon which has less number of hydrogen, and this BH will attach to this carbon. Again this reaction will happen. two alkyl group will get attached to BH, and in third again you will use another propene, result in formation of trialkyl borane. So this compound is formed trialkyl. So 3 propyl group has attached to the boron. Now what happen in presence of H2O2, hydrogen peroxide and OH negative, it result in formation of propane 1-ol. Okay, propane 1-ol. So this reaction is according to the anti-Markovnikov addition, which as a result you get propane 1-ol. So this is hydroboration oxidation reaction. Second reaction is coal-based reaction. In coal-based reaction what happen? So when phenol is treated with NaOH and then you will react with CO2 and acid, it result in formation of 2-hydroxybenzoic acid or called as salicylic acid. Suppose you have phenol react with NaOH, you will get sodium phenoxide. In presence of CO2 and H+, what happens? CO2 will get attached, H will also get attached to the CO2, result in formation of 2-hydroxybenzoic acid called as salicylic acid. Similarly, if you talk about the Reimer-Tiemann reaction, in this reaction what happen? You will react phenol with the chloroform. Instead of CO2, you will use chloroform, which is CHCl3 in presence of NaOH, and what happen? CHO group will introduce into the ortho position of the phenol. Again you have taken phenol, CHCl3, NaOH, result in formation of this product. Again with presence of NaOH, CHO product will get attached at the ortho position, and in presence of acid this N will get removed, result in formation of salicylaldehyde. Next reaction is preparation of ether. From preparation of ether, this is called as Williamson synthesis. So in this reaction what we can take sodium alkoxide and we will react with alkyl halide and it result in formation of ether. Okay, and in this reaction you can form symmetrical as well as unsymmetrical ether. Symmetrical means both the R groups are same, and unsymmetrical both R groups are different. So there is a reaction, you have taken CH3Br in presence of tertiary butyl sodium tertiary butoxide. What happen? This O negative will get attack this carbon. Okay, so this nucleophile will attack and this Br, jo weak nucleophile, will get removed, result in formation of CH3O, CH3 and NaBr. So in this reaction what is happening? One nucleophile is displacing the another nucleophile. So this reaction is substitution nucleophilic and this is bimolecular reaction. So this is SN2 reaction. And remember, this reaction is only possible when alkyl halide you have taken is primary. When you have taken primary alkyl halide, then you can get ether. But if you have taken secondary and tertiary, it result in formation of elimination reaction. Elimination reaction happens and result in formation of alkene. So this reaction is called as Williamson synthesis. Now we talk about the important reactions from the amines. So first reaction is Gabrielthalamide synthesis. So in this reaction, first you will take thalamide. It is treated with the ethanolic KOH solution. So KOH ethanolic solution you will take, result in a formation of potassium salt of thalamide. So here what happen? K will replace the H, you get potassium salt of thalamide, and then you will react with the alkyl halide. Okay, alkyl halide result in formation of an alkyl thalamide. So K will get replaced by the R, and last you will react with the alkaline hydrolysis form. So then you will do alkaline hydrolysis, result in formation of primary amine. So remember, in Gabrielthalamide synthesis you will get primary amine and you will get only aliphatic primary amine. You won't get aromatic primary amine. Second reaction is called as Hofmann bromine amide degradation reaction. In this reaction what you will do, you will take an amide, you react with bromine in presence of aqueous solution of NaOH. So when you have taken amide, which is C double bond O NH2, so when it will react with bromine NaOH, it result in formation of amine, which is RNH2. Important point of this reaction is that amine produced includes one carbon less than the present amide. So amide, you look at this carbon, so here one carbon is less, so that's why it is called as degradation reaction. So in the product you will get RNH2, Na2CO3, NaBr and H2. Next reaction is called as carbon amine reaction. So this reaction is used for the detection of primary aromatic all the aliphatic amines. So in this reaction, aliphatic and aromatic primary amine react with the chloroform and ethanolic KOH. Okay, and it produce something called as isocyanide or carbolamine, which is RNC. NC is called as isocyanide, and it is a foul smelling substance. Okay, so whenever this reaction happen and if there is a foul smell is coming, it shows that there is formation of isocyanide or carbolamine. So this reaction is used for the detection of the prophetic or aromatic primary amine. Next test is called as Heisenberg test. Okay, so this name reaction is Heisenberg reaction. So in this we will differentiate between the primary, secondary and the tertiary amine. Suppose you will take Heisenberg reagent called as benzene sulfonyl chloride, which is C6H5SO2Cl. So when benzene sulfonyl chloride react with the primary amine, what happens? This H and this Cl will react and result in formation of this product called as N-ethyl benzene sulfonamide. Now this, if you look at this compound, what you will see, there is a hydrogen, and this sulfonamide group is a very strong electron withdrawing group. As a result, this compound is acidic and it can easily react with the alkali. So in alkali it can easily react because they have a acidic H here. Okay, so when reaction happen with the primary amine and the compound which is formed is soluble in alkali, if it is dissolved in alkali, that is the primary amine. Similarly, again you have taken benzene sulfonyl chloride, again you are reacting with the secondary amine. Now H and Cl will react with each other, result in formation of N and diethyl benzene sulfonamide. Now important thing is there is no H, acidic H is present. So no H is present. So in this reaction H was present, but here there is no H. As a result, this compound does not react with the alkali, so it is insoluble in alkali. And if we talk about the tertiary amine will have C2H5 group on the 3 side. There is no hydrogen, so it cannot react with the benzene sulfonamide. Okay, so this is the test for detection of primary, secondary, tertiary. Primary will react with the benzene sulfonamide but will dissolve in alkali. Secondary will react but it is not dissolved in alkali, but third, which is tertiary amine, does not react with the benzene sulfonamide. Next important reaction is the coupling reaction. In coupling reaction, you can take benzene diazonium chloride and you will react with the first will react with the phenol in presence of base. It results in formation of the compound. Here what happened, HCl is removed, result in formation of this compound called as para-hydroxyazobenzene. This group is called as azo group, chlorine negative and H2O. So it results in a formation of dye which is orange color. So there is orange color dye is formed. Next we can take benzene diazonium chloride, will react with the aniline. Again H and Cl will react, result in formation of para-aminoazobenzene, and chlorine and H2O is formed. Again this is another dye which is formed, which is a yellow color dye, and these reactions are called as coupling reactions. I hope you liked the video. If you have any doubt, write in the comment section. So see you in the next video. Bye.